Hi, 12. Before we move on to the next set of reactions, we're going to spend one lesson doing the nomenclature of some carbonyl compounds. So we need to sort of have these naming systems in place if we're going to be able to effectively discuss and name products that come up in a lot of the questions. It's nothing particularly fancy, but it is quite important that you're able to name these, and there will be questions in your exam that require you to do this. It won't correspond to a huge number of marks, but it is going to be there. So we're going to start first with esters. Now, these ones you should be a little bit familiar with at least. It does slightly come up at GCSE. Now, all the esters, they take the form of this. So we've got one section, you can think of this as the bit that came from the acid. So if we form the ester by a condensation reaction between a carboxylic acid and alcohol, this part comes from the acid, this part comes from the alcohol. Now if I put this one as R1 and R2, we can establish a sort of naming system for them. So the general name we're going to have for the ester is R2-yle R1O8. So we're going to look at whatever R2 is, put yle, a bit like we do with methyl, ethyl, propyl, butyl, and then we're going to look at whatever R1 is, and then O8, the suffix for an ester at the end. So if I do an example, we've got this molecule here. So the first thing we need to work out is which part's the acid, or which part came from the acid, carboxylic acid, which part came from the alcohol. So looking at this came from the alcohol, as it's directly bonded to the oxygen, just like this. This side's got the carbonyl, this bit is the bit that came from the acid. So R2, if we mirror this thing, the thing that's the yle, is 2 carbons, so this is ethyl, and then R1 is 1, 2, 3 carbons, so that is propanoate. Now make sure to include this carbon when counting it. A mistake some people make is they only just look at these 2 carbons here, so they go it's ethyl ethanoate, but it's 3 carbons, so it's a propanoate. That comes from it being from propanoic acid. So you take ethanol and propanoic acid. If you react those two together, so you have to heat it under acidic conditions, and it's an equilibrium reaction, so you get a low yield, but it would form ethyl propanoate. Right, so we're now introducing a new functional group, which is called an acyl chloride. So these are going to come up a lot. They're very highly reactive, but they're very, very useful. So it's also a carbonyl. So we've got our carbon chain bonded to a carbon, which is in a carbonyl, and then we attach to that a chlorine atom by a single bond. So these are very, very highly reactive. Now these are quite simple to name. You just require the suffix oil chloride. So if I draw out one, so I need to work out the length of the carbon chain here. So we've got 1, 2, 3, 4, 5. So 5 has the prefix pent. So this is pentanoyl chloride. Now the next new one we're coming across is an acid anhydride. So these are they're also highly reactive, and they're kind of used interchangeably with acyl chloride. So they're going to come up together an awful lot. So they can both be used for the same function, but they have different sort of niche uses. Now the acid anhydride, we've got the anhydride. So it's like we've had sort of water removed from an acid, and in this case it's referring to a carboxylic acid. So acid anhydrides, they take the form of this. So we've got Two carbon chains, they'd be different from each other, could be the same. Two carbonyls linked by a single oxygen in the middle. Now the reason why it's called an acid anhydride is that you can think of these having been formed from two carboxylic acids that have undergone a dehydration reaction. So if we remove water from this and then link them together, we get the acid anhydride. Now, the acid anhydrides, I said these R groups don't need to be the same as each other. They can be different, but those aren't really used, as they're not very useful if they are different. All the ones you're going to come across at A level, they're always the same as each other, so it's symmetrical down the middle. So there's always going to be a plane of symmetry. The R groups will be the same. That makes naming them a lot easier. Now, for naming these, it's just going to follow, the suffix is oic anhydride. So what we'll need to find is just what's the length of the carbon chain, and then put that prefix in, like pent or bute, and then just put oic anhydride at the end. So if we look at an example, so this molecule here, it's symmetrical. We can see there's a plane of symmetry down the middle. There's 1, 2, 3, 4. 1, 2, 3, 4 carbons on either side, which gives us the prefix bute. So it's butanoic anhydride. And that is about as difficult as you're ever going to see with those. Then they're not going to do any difficult ones really for those. For the acyl chlorides, they might ask you to sort of like whack on a hydroxy group on it. So when the alcohol group is not the primary functional group, they call it hydroxy. So this would now be 3-hydroxy. So they can get more difficult with the acyl chlorides. So this would be 3-hydroxy pentanyl chloride. They're not going to do anything complicated at all with the anhydrides. They're always going to be straight chain, symmetrical on either side. Okay, we're now going to look at amides, and amides really can get rather complicated, but there are some simple rules we can use. So an amide is a carbonyl group bonded to a nitrogen. Now we're going to work through primary, secondary, tertiary amides. Now primary amide has 2 hydrogens attached to the nitrogen. So you can think of it's only got one thing attached to the nitrogen other than hydrogens. So for these, you name them just like you would with like a carboxylic acid. You're just looking for the length of the carbon chain, and then you put the suffix anamide. So if I draw out an example, so this is a primary amide. It hasn't got anything else other than hydrogens attached to this nitrogen aside from our carbonyl chain. You look for the number of carbons. So we've got 1, 2, 3. That gives the prefix prop. So this is just propanamide. They could make this more difficult, so they can start to put branching. They could put hydroxy groups on. So if I put on, let's say, a chlorine there, that becomes 2-chloro propanamide. Right, so we're then going to look at the N-substituted amides. So N-substituted, as in we've substituted the hydrogens for something else on the nitrogen, and this unlocks secondary and tertiary amides. So a secondary amide, we've still got our carbonyl chain bonded to our nitrogen, and then we've got one R group, so one sort of carbon group, and then one hydrogen. For a tertiary amide, we've got 2 more R groups. They can be the same, they can be different from the thing over here, where we've got no hydrogens left on the nitrogen. They've both been substituted for some sort of carbon chain. So for naming these, they follow the same rule, it's just how many groups we attach onto the nitrogen. So if I do one as an example, So we need to, we treat these almost like branches, so we say they're coming off a location, but rather than saying that they come off carbon number 2, which is what we did for the 2-chloro over here, we say they come off the N. So rather than saying 2-methyl, we say N-methyl. So we've got an N-methyl group. We do a capital N, methyl, and then we put, at the end, we put just the same as if it was, just the same as we did over here. So we put propanamide because it was 1, 2, 3 carbons. This one is 1, 2. Make sure you count the carbon in the carbonyl. So this is ethanamide. So this is N-methyl ethanamide. If we put, if we don't put the N there, so methyl ethanamide, I mean that doesn't work for 2 carbons, because if we put a methyl group on, it would become a propanamide. But if it was